So today we're going to be talking about rhythmic entrainment, which is the process by which we synchronize our internal metronomes, our internal oscillators, to the external rhythms and patterns of music. So as an outline, I'm first going to be talking about what is rhythmic entrainment exactly, and then I'm going to talk about the different levels of entrainment, which I have here as neuronal, perceptual, autonomic, motor, and social. And then we're going to talk about the neural pathways, so the exact processes that are happening in the brain, and most importantly, the connection to emotion. So why does rhythm make us feel a certain way? And lastly, I'm going to talk about the applications in medicine and music, because we are the Center for Music and Medicine. So what is rhythmic entrainment? It's the process by which two autonomous oscillating systems synchronize patterns of oscillation. So the important word here is autonomous, and that differentiates rhythmic entrainment from like a tuning fork. And you hit a tuning fork and it causes the other tuning fork to vibrate. That's not rhythmic entrainment because the tuning forks don't have autonomy. Resonance, that's the right word. Okay. So why is this important? It's important in pretty much all of life. Music, walking, conversation, everything in life has a rhythm. And we're constantly producing rhythms. If you take a moment and notice it, every single aspect of life has rhythm in it. So rhythmic entrainment specifically can occur symmetrically or asymmetrically. What this means is that it can occur between two oscillating systems that synchronize to each other, or it can occur asymmetrically, like when we listen to music, we adjust to the music doesn't adjust to us. And importantly, entrainment is experienced as a pleasurable or desirable state, and that's the connection to emotion that I'll be talking about. So first of all, I'm going to show you guys a physical example of entrainment. And this is a system of 5 metronomes, and they start off at completely different speeds. But through the process of entrainment, they begin to synchronize, and they're only linked by the platform that they're on. So I'm going to speed this up a little bit. And you can see now that the metronomes are all in time. So the point of this demonstration is that rhythmic entrainment is a physical phenomenon. It's something that happens physically, not just to our brains, but to other oscillating systems in the world that don't have consciousness. So a couple quick definitions. The tempo of a piece refers to the overall speed, in essence the BPM, how fast it's going through time. The meter refers to the hierarchy of notes, the perceptual hierarchy. So for example, waltzes are grouped into 3, so 1 2 3 1 2 3. A 4/4 time signature would be 1 2 3 4. And rhythm refers to the duration of a series of notes, so how they're grouped specifically into units in the meter and in the tempo. So an example of this would be like 1 2 3 1 2 1 1 1 1, just like it's the variable part. So the first process of rhythmic entrainment is neural entrainment. And this is the process by which neuronal populations in our brain fire synchronously in response to not just auditory stimulation, but just synchronized in general. And it's proposed to be a system of communication through the brain and the basis of all brain activity, including behavior, cognition, and emotion. And what's really relevant in this discussion is the fact that it's been shown that they entrain to auditory stimulation. So a rhythmic stimulation from outside can cause neurons to fire synchronously in response to that stimulation. And that just shows that this phenomenon of rhythmic entrainment is physical. This is something that's physically happening in your brain. And this is the basis of all the other types of entrainment that I'm about to talk about. So we're going to start with perceptual entrainment. And this is the process by which we integrate audio signals from outside into a perception of tempo, meter, and rhythm. Those words that I just defined. So the way this works is somehow when we're listening to music, we create a mental image in our heads of tempo and of rhythm. And so in our brains, in real time, we're forming this image of 1, 2, 3, 1, 2, 3, 1, 2, 3, where some notes are accented higher than others, and it forms a pattern. This is a form of pattern recognition. And the brain is naturally wired to perceive this, which we know through the phenomenon of subjective accenting, where in cases where there's a constant auditory stimulus that doesn't change, people will subjectively hear accenting. So like a tick-tock, 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 in cases where the actual sound is just one tick, 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 tick. And what that tells us is that our brains are hardwired to perceive meter. And an explanation for how this works is the theory of dynamic attending, that says that the periodicities in musical rhythm are perceived by the entrainment of attentional processes to the periodicities of the music. So frontal lobe processes are responsible for our perception of meter. They're responsible for our noticing some notes as stronger than others, weaker than others, creating this pattern of cyclic motion that carries us through music. One point that I'd like to make is that for efficiency in our brains, only the difference between our internal rhythm, our internal perception, and the external signal is processed. Next, we have autonomic entrainment. And this is the synchronization of autonomic biological rhythms, such as respiration and circulation, to the auditory rhythmic stimulation. And this has been shown in studies, and you guys all know that when you're listening to fast, hard, upbeat music, your heart rate goes up, your breathing goes up. When you're listening to calming music, your heart rate goes down. This is intuitive stuff that has been shown in studies. And one point is that it's a relatively slow process compared to the other processes of entrainment. And sometimes only an approximation can take place. For example, if you're listening to music at 150, 160 BPM, your heart rate's not going to go 160 BPM, but it will rise to an approximate level. Motor entrainment. This is a synchronization of motor actions, physical actions, to the auditory rhythmic stimulation. And this can happen as soon as the beat is perceived, but it's rooted in perceptual entrainment. So in terms of like a hierarchy, the perceptual entrainment comes first, and then motor entrainment, conscious physical movement. The perception is a prerequisite for that. So in the lab, it's measured by asking participants to tap along to an auditory stimulus. But in real life, we see this in dancing, in grooving, and bouncing, and vibing, in both vocal mammals like humans and non-vocal mammals. So in a study by Cook, I believe it was like a sea lion that they studied that was able to rhythmically entrain to an auditory stimulus. Just something interesting. And the last form of rhythmic entrainment, the last level, is social entrainment. And this is the synchronization of two or more people singing, playing instruments, dancing together. This form of entrainment is rooted in the previous three forms. So for social entrainment to take place, it requires perceptual entrainment, it requires motor entrainment, and it requires some level of autonomic entrainment. This includes interpersonal synchronization, the synchronization of movements between you and another person, It's been shown in studies that applause has synchronous behavior. So there's patterns of highs and lows in a crowd clapping. An idea for why we socially entrain with each other is that social synchronization leads to a sense of empathy and mutual bonding between members of the in-group. Now, how does this take place in the brain? Each level of rhythmic entrainment has its own pathways throughout the brain. And I'm not going to dig in too deep into this, but you can see that perceptual entrainment has a lot in common with timekeeping in the body. So cerebellum, parietal lobe, sensory motor regions, premotor cortex, motor cortex, basal ganglia. That one's important. The autonomic level involves the insula, cingulate cortex, amygdala, hypothalamus, a lot of base level kinds of processes in the brain, reticular formation. The motor level involves the entire motor system. So the motor and premotor cortices, the supplemental motor area, cerebellum, basal ganglia again, and the vestibular system. And then the social level, again, requires all the previous ones, but also something important in the social level is the ventromedial prefrontal cortex and the posterior cingulate and precuneus. And these areas are involved in self-related mental representation. So your self-image is important in synchronizing with another person. I think that makes sense. Now, the key brain area involved in rhythmic entrainment is the basal ganglia. And the main function of the basal ganglia is planning and carrying out movement. And it's involved in almost the entire process of rhythmic entrainment. So I have an image here showing the location of the basal ganglia in the brain. And one important thing about the basal ganglia is that it's attached to the limbic system, which is here, and it interacts very closely. So specifically with the substantia nigra, which produces dopamine in the brain. So it's proposed to be the connection between rhythm and affect. It answers the question, why does following a rhythm make me feel good? Why is it pleasurable? Why does it make me feel emotion? That's thanks to the basal ganglia. Now, this is the affect and emotional response. It's been shown that being in synchrony with music, vibing along to music, is a pleasurable state. In fact, there's a name for it. It's called groove. Groove is the drive and desire to move along to rhythmic stimulation. So how does this work? First, there's the autonomic component. When your autonomous system entrains to music and elevates or lowers in that way, it already forms a part of your emotional response. Your autonomous system is already an integral part of your emotion. The second part is what we just said, basal ganglia. It's involved in the movement, the rhythm, and also the reward processing. So when you hit a vibe, when you're freestyling, when you're in the moment, in the flow, and you get the rush of dopamine, that's because of the basal ganglia. Third, there's a social component. When you're vibing with others, there's an emotional response related to that. So here again is a limbic system, which is involved in emotion, and we can see that the basal ganglia is kind of like wrapped around it, just again showing how closely interacting these two systems are. So how do we use this knowledge in real life? How do we apply it in medicine and in music? Well, in medicine, what we are involved with a lot in in this center is Parkinson's disease. So we know that patients with Parkinson's have impairments in the basal ganglia and substantia nigra. So they have issues producing dopamine, issues with rhythm, with gait, with speech. These are all processes that require rhythm. Knowing the process of rhythmic entrainment explains this. Because they have issues with the basal ganglia and the substantia nigra, they cannot properly entrain rhythmically to outside sources, to even like their own internal rhythm is just off. So in medicine, we've seen the use of rhythm-based interventions such as rhythm therapy, drum therapy, dance therapy, to help alleviate symptoms of Parkinson's disease, to help improve speech and gait through recruitment of alternative pathways. So by trying to entrain to an outside source like a metronome, these Parkinson's patients are promoting alternate pathways in the brain that don't necessarily go through the damaged areas of the basal ganglia, and that can help with their speech, with their gait, with their walking, in all areas of life. So second application in music, aka what is a vibe? So with this knowledge of rhythmic entrainment, we can start to parse out different areas of music that have not been well understood in the past. For example, what is a vibe? Well, a vibe is when you're rhythmically entrained to either the music or to another person. What is a trance state? A trance state has been shown to be when you're completely rhythmically entrained. That's perceptually, autonomically, motor, like physically. It helps to explain chills, like why we get chills when we listen to music. Of course, there's all kinds of other pathways for emotion involving music, but one pathway is through the basal ganglia and that release of dopamine. We can explain why we want to groove. When we're moving, when we're in like a vibe, the brain starts to release dopamine, and that's something that builds habits. So we start to crave that surge of dopamine. We associate this rhythmic entrainment with that dopamine, and that makes us want to move in order to get that dopamine rush. Now, freestyling is, I kind of consider, the next level of rhythmic entrainment. You do have to be completely rhythmically entrained in order to freestyle, but there's kind of another level to it. So you're not just in the rhythm, but you're also producing rhythmically. If that makes sense. So in conclusion, we synchronize our internal tempos to external tempos through rhythmic entrainment. The process of rhythmic entrainment happens on multiple levels. The neuronal level, which is the physical firing of neurons. The perceptual level, our conscious perception of rhythm in space and time. The autonomic level, our bodies responding unconsciously to the rhythm. The motor level, the physical conscious movement, dance. And the social level, when you're synchronized to other people in real time. The widespread processing in the brain involves motor areas, emotional areas, and the basal ganglia. And one thing that I want to mention is that the perceptual process, just perceiving a beat, perceiving a rhythm, already involves premotor cortex, motor cortex. So when you're just listening, not doing any conscious physical movement, when you're just listening, perceiving a rhythm, your body is already in motion in some way. It's already planning to move, it's already moving. So that tells us that this is a natural evolutionary process in the brain. So thank you for listening.
I have a follow-up question. If you go back to the slide on the extension of what we need to learn about, just a couple slides that you had there. So, what are your thoughts about freestyle? You started talking about it, but you're basically suggesting, if I understood you correctly, that when somebody freestyles, they are using entrainment, and yet the prefrontal cortex is of necessity active in order to produce creative content, right? Because we're talking about speech network activation also, right?
Right. When I talk about freestyle, I'm not just talking about freestyle rap.
Okay.
I'm also talking about like improvisation on guitar. I'm talking about freestyle dance.
Okay.
I'm arguing here that rhythmic entrainment is a baseline necessity in order to freestyle. It's the framework of what you freestyle on top of. And if you're not rhythmically entrained, then you can't freestyle.
I see.